I'll just briefly introduce everybody. This is John Willis, Adrian Cockroft, Ben Saller, Jeff Lindsey, Bill Farner, and Bill Grant. And Brian Grant, sorry, excuse me. So, yeah. So, I'll turn it over to you.
Okay, yeah, so what I'm going to do, why don't we just do a little quick intro, keep it to like a minute and a half, 2 minutes of just, I'll just give you my background really quick. I'm Botchgaloop on Twitter, John Willis, doing IT for 35 years. I actually was one of I was the 9th person in ops code, so I won't go all the way back to the mainframe days, but more recently I've had a couple exits. I had a company called Instradius, we sold it to Dell, and then about 4 months ago, I think tomorrow, I sold a company to Docker called Socket Plane. So anyway, and now I'm a technical evangelist at Docker, so just having fun. Adrian, you want to?
Okay. Adrian Cockroft, mostly known as that Netflix guy for doing way too many presentations for the last few years. Year and a half ago, I joined a VC firm, Battery Ventures, and basically I'm doing even more presentations. So yeah, go find me on Twitter and SlideShare and whatever. And I'm doing a couple of talks tomorrow at the conference.
Hi, Ben Saller. I work at Canonical. I'm one of the original authors of Juju, but not the only original author of Juju in this room. And so we work in the service orchestration space there, and yeah, happy to talk about this.
Hello. I'm Jeff Lindsey. I'm kind of known for just doing a lot of open source stuff. I actually worked on proto OpenStack when it was in NASA Nebula days. And I actually worked on Docker as an independent contractor when it was a Skunkworks project, and then was involved a lot in the conceptualization of the project. And has since worked on a lot of open source projects. Doku was the first killer application for Docker, and a bunch of other things for Docker, Registrator and Logspout, and a bunch of other things. So now we have Glider Labs, we're a consulting company / systems R&D lab. So a lot of opinions on everything.
Hi, I'm Bill Farner. I've been working at Twitter for about the last 6 years. Started working on a project called Aurora, which is now a top-level Apache project that, if you're not familiar, is a framework that runs on top of Mesos, and basically how we do all of the service deployment at Twitter.
I'm Brian Grant. I work at Google. Previously, I worked on Borg and then founded the Omega project. And more recently, I've been working on Kubernetes.
Cool. All right. So orchestration, right? So let's set the kind of the baseline here, right? Because it's an overloaded term, right, in our industry in general. I think the more recent examples of orchestration would kind of represent some of the tools that you guys have been working on. Why don't we do another run through? Is what is orchestration in your mind, and how do you, if you use it in an implementation right now? So an example of not only what you think orchestration is, but like what is an example of something that you either work with a customer or actually use in your own implementation or some project? Make sense?
Sure. Yeah, well, I don't get to do much myself nowadays, but been spending some time thinking about this area. So that I see there are really two kinds of orchestration, or two flavors of this. One is, let's say I want to assemble a whole pile of containers out of Docker Hub or somewhere into something, right? So I need to be able to figure out what order to start them in, how to hook them all together, how to make a complete application or out of the various components. So that's one clear orchestration problem that the sort of Docker community sort of needs to do, and we've got Compose and things like that that are sort of going after that bit. The other orchestration is something that, so one of the sort of trouble I have with that is like Netflix never seemed to need that, right? So when you've got a service that you're running, the kind of orchestration you need there is about deploying an individual microservice. And so the orchestration that Netflix has built is actually solving some different problems, which is more about how to sequence a new piece of code into the existing system. So you do a canary test, you put it in test, and then you move from test to production, and you do a canary test in one region. And if it passes that, you move it to the next region, move it to the next region. And that's that's also orchestration, but it's coming at it from completely different viewpoint. It's much more about, I'm trying to automate the flow of code into an existing running system rather than trying to boot something up from scratch.
Netflix, wind up.
I think the only time we really booted up from scratch was when Netflix went east-west, so it was all running on US East, and then wanted to run all of Netflix in US West as well, so that you could switch the traffic back and forth if a region ever had an issue. And so that involved effectively trying to figure out how to boot stuff up from scratch. What was the sequence of things that needed to be started in the right order? But it happened so infrequently that it basically was always a manual process. Launching a brand new thing, turns out it was infrequent enough that it never quite got to the point where it needed automation, right?
Yeah, I think you touched on a lot of great stuff there. A couple of other points. So we talked a little bit about deployment, a little bit about automating the processes around lifecycle. One of the other important components that I think people are looking for when they talk about orchestration is the ability to capture that operational intelligence and reuse it in a variety of environments. And that doesn't necessarily fall out of any of the existing orchestration solutions without a little bit of pre-planning. So yes, it is complicated to deploy a class of software that's sort of not cloud native, the way you describe a lot of the Netflix properties, is already being microservices, already being balanceable. But there are entire categories of service where the operational smarts, if you're a data scientist, you don't necessarily want to become an expert in managing all of the big data services and understanding all of the overlay networks and understanding all of this before you can start hacking on your big data problem. And so I think orchestration is a way to capture enough of the knowledge at those various tiers that makes them approachable by people that aren't necessarily domain experts in those fields, and be able to operate that software at scale, again, without having to become expert. So I would say that's important.
Jeff? Deep thought there.
Yeah, well, I'm just thinking, because I actually hate the term orchestration. I've always been sort of confused about it because it's been used in so many contexts, right? It could mean, doing like simple automated, bash and SSH to, Chef and Puppet to cluster managers like Mesos, et cetera, or things like Juju. So there's so many different things that it could be, and different parts of the stack, or different layers you can think about it. It could, arguably maybe distributed coordination, just using etcd is kind of an orchestration thing. Service discovery is kind of an orchestration thing. Again, if you have really loose coupling, like at Netflix, and you can just kind of like throw things up, and you don't have to worry about kind of the dependencies and the order of operations, it's a little bit easier. It's more focusing on that deployment. Yeah. But then also you have platform as a service people who kind of think of orchestration as high-level workflow. So I don't have an answer. I don't think we should be saying orchestration. We should be talking about something more specific, but.
Oh, it goes to the Mesos guy.
Yeah, and actually, interestingly, I think I have a totally different answer. So I tend to be thinking about orchestration a lot more from the cluster management perspective than the developer environment and what it takes to run an application. So this kind of reflects in the systems that I've been working on and the things that you see in Apache Aurora. A lot of it is around utilization and availability. So we're trying to focus on things like making sure that when certain different parts of the infrastructure fail, that the application still has enough capacity to be healthy, and that things can recover very quickly, and that we've basically arranged things in the right both order and also location, so that again we're insulated from failure, but also sort of in an optimal performance perspective, performance arrangement. But and then of course there's the utilization where I think our public figures are that we operate clusters of tens of thousands of machines, per Apache, Aurora, and Mesos cluster, and every percentage point of CPU that we can save, that's really huge. And right now, some of the things you're starting to see that are coming into Mesos and are also making their way into Aurora are actually about going further and actually sort of taking more advantage and oversubscribing the resources in the cluster.
And Brian, I want to hear your answer definitely. But is there a theme here? And this is where I get to ask dumb questions. But like the hardware guys care a lot more about this than the cloud guys. Is that kind of what we're seeing a little bit? You're about. I'm sure his answer is going to be similar to load balancing and Omega and stuff like that. How you squeeze things in, how you get the best fit. Is there? I guess I'd like to hear both your answers. Then I'd love to hear your comment on just orchestration in general. Yeah,
I think you're right. And like Jeff mentioned, it's a really overloaded term. So I think we kind of use the definition that we like the most and that is closest to us.
I actually have the definition written down here.
There we go.
So, the original narrow technical definition of orchestration was execution of a defined workflow. And that's how I think about orchestration. It really has a narrow role. And the things we've been talking about are really much broader, and the term has been stretched to try to cover these other cases, but really it's all about automation of your operations, and raising the level of abstraction was another point that I really strongly agree with. But people really need to think, when everybody starts out with a little toy example that is like a shell script with a couple of steps to execute in a particular order, but these things are always inherently brittle. Like if something happens in the middle, the script is not going to deal with that. If something fails, the script is not going to rerun itself and recover that thing. So I think a really important aspect is, especially as you try to grow up to larger scales and run in more environments, is self-healing. And part of that is the rebalancing and the utilization, making sure things are running in the right place, but just self-healing very broadly. Keep everything running. Like we have workloads that people start at Google and they can leave the company and it will still be running 2 years later, right? So, and in fact, we have to run programs to try to squash things that should no longer be running because of this. So I don't know if you were finished.
That's great.
But so Brian, I'm going to open it up too. There's going to be tons of open for questions. But so I'm not a computer scientist. I play one on TV. I tried to read that the Omega paper. And I got a little bit out of it. So I was wondering, it might be helpful, in that paper it talks about, kind of the two levels when you guys went from Borg to Omega. And if I'm totally off course here, correct me. But and you said there was a monolithic, then there was kind of a two-level pessimistic, and then there's a shared state optimistic. You want to talk about that? Like educate the general masses of what that actually meant?
Yeah, I think there are... and definitely I can answer that specific question, but so the original board system was fairly monolithic at its core, and it had what we called a master. And actually, we finally published a paper in Eurosys. If you want to read the details, there's a pretty good overview in the board paper. Just search for board paper, you can probably find it. And originally, the master was single-threaded. It contained the scheduler as well as the basic state machines for managing the lifecycle of all the entities in the system. And there was an agent on every node, which we call the Borglet. And some of this terminology is carried over into Kubernetes to some degree, but there was just a single scheduler, and that scheduler had to work for all workloads. And you can add scheduling policies that make different scheduling decisions for different workloads, but it's still just one team more or less, that was in control of that critical body of code that had to adapt it to the needs of every workload in the company. So I think that the number one thing we learned from Omega that's more important than the details of how the scheduler works is just componentization. So that's something we really tried to take to heart in Kubernetes, whether it be multiple schedulers, which was one of the focuses of Omega, or multiple workload controllers or multiple verticals like in Mesos. We actually worked with a number of the people working on Mesos very early on in that project. I think it's interesting to see how the verticals have developed in Mesos. In Kubernetes, we've taken a somewhat different approach to how to grow the ecosystem. I think that's another thing. As people want to automate more and more of their operations, they will need to add more and more components to automate individual responsibilities. So you want to make sure that the ecosystem can accommodate the addition of these components in a sane way. Mesos has a 4 or 5 year lead on us in terms of maturity. So early on, our focus in Kubernetes has not at all been on scale. Our initial goal is pretty modest because more than 90% of our user base only needs a few dozen nodes. So we haven't pushed too hard on that. Mesos is definitely more scalable than Kubernetes today. But in terms of where Kubernetes can be eventually, there are no inherent blockers to achieving the same scale as Mesos.
So for the rest of you guys, I keep hearing this on Twitter, and it's more recent now. People are saying, stop trying to be like Google and stop trying to be like Twitter. And you know, like they're a special breed. And I don't believe that, right? I mean, I think that what we're seeing is commoditization of what you guys at Google, John Wilkes did a presentation at Lisa about 2 years ago where he kind of exposed what you guys were doing with Omega. And it was a fascinating story to see that 2.5 years ago of like bare metal machines and you know, everybody kind of talked about what you were doing, but unless you worked there or you signed an oath of death or something like, you couldn't tell anybody. But I think that now, I think the world is becoming more like Yelp. I think I met somebody at Yelp said they run like 11 containers a second, something like that, right? I mean, you know, we did the mythical 2.2 billion containers a week from Google, right? I think, you know, I think the world is changing that model probably is going to be, I don't know if you guys agree or disagree or.
Yeah, I don't think it's the scale that you're operating at. It's the properties that you demand of the infrastructure. Everybody wants the self-healing. Everybody wants the dynamic recovery, the load balancing. The problem becomes an economic function for many people, whether or not they can run 8 machines to have some kind of bespoke paths to do the one piece of software they have. It's not worth it in some sense, unless that piece of software is mission critical, to carry a lot of infrastructure. And it's very difficult to specialize a team to gain the knowledge to do that for a small organization. So when we talk about things like Kubernetes or the kinds of software that we have with Juju and the other things, what we're really trying to do is exactly what you were talking about, make those best practices available by capturing the automation stylings of the larger players and presenting them in a cost-effective way. And I think everyone is interested in that, absolutely.
Yeah, I think that you've got to look at what's happened over the last few years. So if you go back 10 years, if you wanted to deploy something, it would be weeks to months because you had to go buy hardware and you have to burn things in and, you know, it takes forever. When public cloud came along, all of a sudden it was radical that you could do things in 5 minutes, that you could boot up an instance and whatever. And now with Docker, it's quite often seconds if you've got reasonably well-designed, you know, smallish containers. So when you can do things in seconds, stuff becomes possible. In fact, stuff becomes so easy that there's no reason not to do it. And that lack of friction means that a whole load of new tooling sits on top. So given that I can deploy a service in seconds, well, you know, if it goes idle for a few seconds, I should shut it down again. And if you look at what AWS Lambda has done, that's kind of like the bleeding edge of containers. They fire up a container to do a single request and they shut it down again if it goes idle for a few seconds. If you send them enough input, they actually keep it alive because you can run slightly more efficiently that way. But, you know, they charge you by the 100 milliseconds for how long you're running your container. And that idea means that you now need to think about, well, what can I do given that is now easy to do, what can I do on top of it? So that's one whole area. Why now, right? Why is this an interesting thing now? What can we do and how can we build this? And the other thing is just the standardization. If you just go to, like I say, you get your standard Nginx or Redis off of Docker Hub or something, you don't need to mess with it. You just need to configure it, plug it into your infrastructure, glue it up with the rest of it. So I think that the componentization, it's like a maturing model, right? We're getting to a later stage of evolution. These are standard pieces of infrastructure. They're well understood. You plug them together. And the problem moves up a level. We're now trying to assemble things. It's an assembly problem. It's more like, I think I said at one point, the next generation of programmers are the people who currently are playing Minecraft. Because Minecraft, you have behaviors, you glue them together, you build bigger behaviors, and you kind of build worlds out of these behaviors. And so that's actually the right mindset for building things out of these building blocks.
I'll say that I think the development best practices and like best practices for just managing software are absolutely universal, and that's what a lot of these systems really do. But the infrastructure needs are definitely not universal. Not everybody needs a Borg cluster or a Mesos cluster. Sometimes just the overhead is a lot, the cognitive overhead.
I mean, if you look at the way we did it, we thought about this at Netflix. We took the Amazon, it's the equivalent of the Borg, right? Was basically the Amazon autoscaling group. So everything that deploys in production at Netflix was an autoscaling group. That was the building brick, right? It might only have one machine in it, but if that machine died, it would be replaced. So there were these immutable AMIs, the launch configurations, and an autoscale group. And it was everything is an autoscale group, and everything was built out of those. And then it became, okay, we need to do upgrades. Well, let's do sequences of autoscaling groups, which we called clusters, so you could have old code, new code, and switch traffic between them. But that is, we took self-healing infrastructure and that level of automation as just a feature of the cloud that we used, right? We were operating above that level and sort of taking it somewhat for granted. And now people, that's kind of what Mesos and things like that are now giving people a more generalized way of doing that. It's a bit more flexible and pluggable, and you can run it in your own data center, but it's still the same basic idea. Right?
This is kind of good. This is one I couldn't ask at Dockercon. Union file systems, evil or not? The reason I ask, I heard a great presentation at Scale where this thing came up about. I'm trying to go the Google guy, but anyway, any thoughts about, I guess there are models that work very well without union file systems for.
Yeah, we don't use union file systems at Google. We don't really consider any of them to be production ready by our standards, and they're also not necessary the way we package our software. We've actually talked about flattening Docker images to just collapse all the layers, and the container would still have a writable layer, but that's 2 layers is a lot different than in layers. So it's interesting. I mean, it allows some kind of cute optimizations, especially during the development phase, but it's not clear that it's actually necessary or desirable for running in production.
That's why I thought I asked. It's an interesting debate. I mean, because the whole continuous delivery pipeline it's been beautiful for Docker for that, right? This idea that you can actually, the original use case was a Postgres database that started at a certain state. You could test it at that state 1,000 times in like 3 minutes, right? So I was wondering, just anybody in general thinks.
Yeah, so we actually decompose our file systems differently than strict layers. We actually decompose them into dynamically composable modules that are bind mounted into the same file system at runtime. So we can actually independently upgrade different components of the application. And if you think about the logical pieces, you have your base file system. Maybe you have some tools that need to be there for debugging, but they don't need to be there normally during production. You may have your language runtime, your actual application configuration. A lot of times you want to update different parts of these things at different times. And the way Docker layers work, you have to rebuild basically from scratch if you want to change anything but the top layer.
Ubuntu's Snappy offering is a great way to experiment with that, by the way.
Yeah, so I haven't played with Snappy, but so I think you can do this with volumes with some effort in Docker. And I think it's actually a better way to package applications. It does require something higher level than what Docker natively offers. You at least need something like Compose or whatever to paste all these things back together again once you pull them apart. But I think once people get experience running in production, it's probably going to go to that direction. You do lose a little bit of the immutability of the whole, but what you get is composability and flexibility at runtime.
So I've had to deal with this in Doku, and part of Doku is build step, which emulated the Heroku build step process, and it created. You had this to emulate Heroku. You had this huge base image, Cedar, and we had a base image called Cedarish that basically re-implemented that. And so and then we had images based on that, and then your application's built on that. So when people are talking about Heartbleed, for example, it brought up all kinds of interesting difficulties and challenges and questions and stuff like this. And one of the first things, though, that I usually try and point out is, that thinking about systems in that way is not how you ideally do Docker. Like when we do production containers, it's like BusyBox and a single binary. You don't even have bash in there, or whatever, or you don't have any kind of SSH. It depends on what you're using, but it's like what you have in your container is not minimal that you're not thinking of it like a host system. But you still have those situations where there is something where part of the chain needs to be updated. And like I don't know of a good answer talking to the Heroku people about this. Like, how do you solve this? Are you going to rebuild everybody's application like the next time they deploy? Well, I guess you rebuild every time they deploy. I don't know. It's like it's kind of a hard thing with this layered thing. But I wanted to point out, though, that the layered file system thing in Docker is a really interesting artifact of the history, the context of Docker, in the same way that there are a lot of decisions in Kubernetes that came from Google. In both cases, I don't necessarily always agree with, but they seem sort of rational to both parties. The layered file system thing in Docker is really kind of a convenience for workflow, and I think it did a lot of great things for sort of like the life cycle managing and building, authoring container images. When we were originally talking about it, I really wanted more explicit management of layers. And you actually had command line tools to kind of manage the layers, and they decided to simplify it so that it would just be based on the Docker file, which was introduced later. But it very quickly you still run into problems with that, which is why some of the early adopters, like people building platforms on top like Deis, actually helped define the volume and host mount interface so that you could actually bypass the layered file system. And so ever since the beginning, everybody's been talking about, oh, you can't do like so-and-so in containers because there's a layered file system. Well, you can, just don't use the layered file system, and that's always been an option. So I've learned to kind of get used to it and learn to work with it. Maybe it's not the ideal, but it's what we're working with now.
Cool. Any other questions from the audience? The other thing too, you might want to do, like, don't be shy, right? Like if you're here and you really still like a lot, you want to get one of these experts to kind of go a little deeper on, the assumption is that everybody in the room is an expert on Docker, everybody's an expert on, you have an opportunity to not be shy and ask some of these, people just basic questions. You should take this opportunity.
What I'm hearing, talk about these things, well, not do some, go ahead, back, well, same
Exactly.
I think there's several totally different use cases for Docker. One is, the sort of doing it right and everything, sort of the native idea, where you probably have a statically linked Go binary sitting on Scratch, and that's your container, and it's 4 megabytes, and you're done, right? So that's a really nice, robust way to put stuff out. But at the other end of the scale, there are people in sort of big old enterprises with these big snowflake monstrosities. They're going, you know what, I could wrap all of that crap in a container. and Yeah, and I can have, I can have my database, my middle tier, my message, my enterprise service bus, whatever the hell I want. I can stuff it all in this thing, and I can put all that in a container, and now I can wrap it. Now I can move that container around, and I've solved a problem I had.
Right. Containers as VMs.
Right, but you're using it as a way to create, create these monstrosities. I mean, and people are going to be doing that. And then there'll be bits and pieces of this stuff, mixtures of these too. So if you go, download a complete thing, let's say you want to build a Internet of Things backend. Do you want to download it as a single container that contains everything that just works and it's got masses of stuff inside it? Or do you want it to be an orchestrated bundle of 20 different containers that all sort of assemble together in exactly the right way, maybe, right? So I think that we're going to continue to have both those extremes, and one of the interesting things about Docker is it does cover that whole range, right?
Yeah, I mean, Docker is a tool, and there's a lot of different ways you can use it. I'm a little bit annoyed, though, that there's sort of like this sort of popular idea of how to use Docker, which is also, for example, all the sort of like a lot of this stuff in there. The Docker Hub standard library are just like these gigantic images, and it's like, like trying to deploy these things. Like in development, it's like, okay, I've done Docker pull once on my laptop, but like you got to do this on every machine. And so I'm really frustrated by
400 meg images.
Yeah. So I'm really frustrated. Yeah. When we go to clients, they're like a gig or more, and
if you have to
like cut that in
something.
half immediately. So I definitely suggest like just challenging the Docker way of doing things sometimes, because I think a lot of what Docker hears are a lot of the developers just playing with it, and that's the feedback that they use because those are the people that are talking to them. I want more people using Docker in production, which will require people to try it, to go back and complain to Docker about these things.
It's the thing where people don't really need.
I think the trick there is to elevate the language that you use to talk about your software and your deployments. You need to be able to articulate what you're doing in terms of models that encapsulate the underlying complexity of the various components. And until you do that, people can't reason about the topology of the software that they're left with. So taking the snowflake and breaking it into microservices might be a very logical step, but if you can't articulate in a uniform way what those components are and explain what the communication dependencies are between them, you're not going to be able to take that apart in a clean way. What you've basically done is just complicated your life. Yes, there are benefits at the end, you know that, you believe it, but that's the kind of work that gets deferred in enterprises in terms of feature development and other things. If what you do is you have sets of reusable components and you start building catalogs of those that hide the complexity of managing each of those individual pieces and expose only the information that needs to exchange between them, suddenly you can talk about doing these things at scale. Suddenly you can talk about automating and connecting these things as Legos instead of just the mound of snow that everyone ends up with eventually.
This becomes a DevOps story, right? Because we saw something similar with Chef, early, right? Like the idea that people would actually pull cookbooks off, build them in development, and then they just throw them right through the pipeline, and those cookbooks that were yanked down would become the production implementation of Tomcat or whatever they were running, and nobody took the responsibility of going through the hygiene process of understanding what was in them. B, even understood whether they should have been broken apart. And so I think when I hear all this stuff about, the kind of black box and, what's in them, like the idea now is you really, just like people learned with Chef and Puppet, you have to take responsibility. And I think with Docker, put my Docker Kool-Aid hat on for a second, it's easier to start from scratch and understand and build what's in it. And if you want to follow somebody, Josh Corman over at Sonatype, he's the CTO over there, he's doing a lot of discussions about supply chain And, you know, so you combine this kind of operational hygiene in that you're going to build your stuff. You're going to host your own images. You still have the sandbox, right? Like anybody, you do want to make sandbox available, right? Somebody wants to try out Spark really fast. That's pretty awesome that you can download a container and try it in a sandbox. And there was an organization I saw the other day, they told me that their data scientists now have this brilliant sandbox where literally they can go through about 6 or 7 data, you know, Hadoop, Spark, you know, try out about 5 or 6 different things in about 3 days, which otherwise would have took them months to get through, right? So you still have your sandbox, but at the end of the day, I think you have to take the hygiene responsibility for how you build things, the bill of material that's in those containers, and you know, so this is really just an old story revisited, and the people who build, you know, build their operational hygiene in conjunction with the developers. Hey, here's the base image for all things. Here's the base Tomcat image, right? Anyway. What happens?
Like RPMs and Young.
Well, conceptually, I think what you have is a very valid model in comparing it to packaging. The difference is that packages are the equivalent of the deployment step. And as we all know, the deployment step is not the life cycle of operating a complicated piece of software. It has none of the properties that we talked about as being desirable, the healing, the load balancing, moving loads around. Those are the operational concerns that if you're talking about packaging stuff so that it's usable in a kind of cloud native way, and you can't facilitate the various workflows that IS or your infrastructure place on that package, then you really haven't obtained anything.
Right, reproducible and reversible.
Right, and so I think where Docker intersects nicely with that space is that people don't think of Docker containers exactly as being an inert deployed piece of software. It's like a snapshotted running thing in many people's minds. And I may be confusing how people actually think about it, but that's what I tend to see. And they then use that as an excuse to think that there is somehow a way that the operational knowledge has been baked into these containers, which anyone that's worked with this obviously knows isn't true. There needs to be a layer above this. The other thing that we're seeing is that there's a lot of tooling and infrastructure that's being built around orchestrating only these types of containers and not dealing with the rest of the enterprise. And so, again, if you have a set of toolings and a language that doesn't extend up to encapsulate what people actually do, you're going to quickly hit those barriers in the real world because perhaps you don't want to redeploy your scalable, highly available database system that the company relies on in Docker containers before you can use it to orchestrate to the things that are its clients. We quickly fall into these traps where people are trying to solve these problems in a variety of areas rather than trying to figure out a model that fits all of these things and raise the level of abstraction so that we can then begin applying tweaks to these models in ways that make sense, that fit the actual operational concerns of various enterprises.
So we have a history of new tools that's better. What have we got now from that advance? And what are we learning? All right, do you want me to repeat that? Yeah, okay. So, I was going somewhere with that question.
Sorry.
And what I wanted to ask was, so we've solved some of those problems before. It wasn't satisfactory. We have some new tools to solve those problems better. What did that actually get us where we are today that we should be glad that we are compared to, the bad old days? And what are we really hurting for?
Well, so I would encourage, if you haven't looked at Juju, to take a look at it. And one of the things that you'll find, we used to talk about it as DevOps distilled. And so what you end up with is a catalog of useful, common, open source software components where the operational knowledge is distilled into a package-like format, but what we've done is captured lifetime concerns as well in a single universal operational model that applies across all of these kinds of software and allows you to assemble them like Legos. And I think that whether what we have in that is the end game, which I would not naively believe, or the stepping stone that every other person trying to come up with an orchestration solution will necessarily have to deal with, there is something there. So I would encourage that as a model towards looking where we actually will end up.
I think we're talking about two different problems. So you solve like RPMs, for example, and then we have like, composition of a bunch of stuff maybe at a higher level than RPMs.
No.
And orchestration is like what happens when you've already got things installed. And
what I was not going to try to do was teach everyone what the Juju's actual model is, but we talk about things like services and the relationship between services. And those are runtime entities.
Yes.
And they allow the pieces of software to interact and affect each other at a layer that's operationally interesting, but has nothing to do with the software itself.
Okay.
So in those packages, we call them charms, they actually capture how to exchange information with things that claim to be able to use them. And that provides the runtime information that I think you are after in terms of more of this has been added as a result of increased load or demand. It's now implicitly wired into the HA layer. It's implicitly connected to the database because the relationship is a logical modeling of your topology, not a concrete instantiation. It's in this logical model, which is viewable as a runtime real thing apart from which pieces those are. So in the Juju world, for example, if you have charmed a database, no one needs to have ever talked to that author to guarantee that their software will work with that database. They only need to claim to communicate on the same interface that it provides client connections on. And that's orchestrated connections, not database level connections. So you connect your web server, it's capable of saying, hey, I need a connection to the database. The admin has drawn this line between these services. Here's the credentials that come back over that relation, et cetera, et cetera. And at that level, we have what I refer to as kind of a P2P orchestration model. The components themselves are able to advertise and exchange the information they need to operate at scale. And then the admin is using a single language, which Juju provides, for orchestrating the entire deployment beyond what the individual non-opinionated charms are able to do themselves.
Sort of like requires and provides, but like
Sure.
on a global system-wide scale.
Yes.
Okay.
Does that help? Or
Yeah, it sounds like packaging instead of for the host, but entire system.
for the runtime of the entire system? Yeah.
Yeah. I don't know.
I drink a lot. I think what you get with this model is immutability, right? And I think that there was a paper written in 2002 called "Order Matters: A Turing Equivalence Machine," and it's a great paper. And it was actually one of the arguments we used to use for Chef against Puppet, because Puppet had an ordering pattern, right? Today, they all kind of normalize out, but Puppet used a dependency graph. And, Chef was very deterministic, right? I think that at scale, and I'd love to hear the scale people answer this question. I think that at scale, when you build infrastructure and you build it on the laptop, and then you build it again in the chain of the flow of the continuous delivery model, and then you build it in production, I think bit or entropy at different stages is going to matter at large scale. And I think if people go on to scale, I think what I like most about Docker and the immutable delivery model is, if you look at the Guilt presentation from last year, right? From the time they do the commit, that process is one meta file with a bunch of immutable binaries that goes through the system. And so the bit, and if you take the DevOps kind of mantra of developers wear pagers, well, developers own everything about that immutable delivery and immutable artifact when it gets into production. And I think that's what we get but you have to buy into the immutable model. And the caveat to that is the whole thing that Josh Corman is talking about, it's Sonatype, the black box that it is when it's there. And that requires us, again, operational hygiene to start putting, bill of materials, do the scans early. Ari Paneer, the guy who wrote M Collective, has a really cool blog article about he operationalizes stuff so that in every container he builds, he's got a container.sh that can tell you everything that's operational in there. So that's what I think you get out of that model, which isn't really the orchestration answer, but.
So orchestration as a matter of actually orchestration is not actually what orchestration is. Two, I don't get an order sequence events through a cluster. There is no global ordering in a cluster. And to pretend, Chef and Puppet are explicit order of programmer versus server dependency topological sort and work through a cluster.
And code path. Code path, something that would show up at scale as a bug built. We proved this with Chef versus Puppet with the topology graph, the dependency graph, that if depending on the order that you build things at scale, that created different bugs. So Mark Burgess went into JP Morgan Chase and turned CF Engine on down to about 5 seconds. And they found out there were 1 billion unplanned changes a day. And they thought they actually had completely built a model of deterministic deployment from configuration management. So I do think that at scale, you will see bugs in code paths that are completely different based on how things are built. If this is built in a different order, or if there's a chain of events of commands and this one is skipped here on this machine, or this one misses the cycle on the 30-minute or 15-minute cycle and this machine doesn't, I think that causes operational, it causes a higher OpEx.
There's a delta here between on a host ordering and global ordering. And the two are quite different.
Well, yeah, distributed systems suffer from all kinds of problems. But there's a lot of corner cases and a lot of things that you run into. But one thing you find is that if you the more immutability you sprinkle around, the easier it gets. There are a lot of corner cases that get tractable when you have immutable systems, and that. The ability to cache something and then know that it hasn't changed, it makes things a lot easier. So this happens in sort of storage systems, databases, all kinds of things like that, and in the sort of coordination algorithms for things. So one of the big arguments we had back in 2009 or something at Netflix was whether we were going to change machines in production and do the sort of chef-like model, or whether we were going to bake AMIs and have them just be all the code is there. And once the code never changes, there's configuration that changes, and there's things that. But basically, to make an immutable code model, and when you've got 500 or 1,000 machines that you think are identical, it's really good if they actually booted from the same AMI, and all the code is the same, and that a whole class of problems went away from doing that. But again, at small scale, it probably is not worth it. But once you get to any kind of scale, you find that a whole pile of problems were just caused by things not being exactly the same when you thought they were.
We try to use it as much as we can. I agree with what was just said, that it's incredibly important, and when you're operating a huge fleet of machines, it's just a nightmare if you can't, kind of assume that things are more or less the same.
Yeah, and being able to express what we call the desired state at a higher level, capturing as many operational concerns as possible, can help you ensure that the system is actually always in the configuration that you expect. Docker containers solve a piece of the problem, and it's a hairy piece of the problem, but Docker containers typically need to interact with storage, they need to interact with networking, load balancing, functions at scale, other microservices. So being able to express as much of that as possible declaratively in a way that's friendly to systems that can self-heal and ensure that the system is in that desired state will make it more robust and more scalable and reduce the ops burden.
I mean, that's where you
What does immutability have to do with distributed systems?
Well, one aspect of immutability is that it is one representation of the desired state. I mean, typically people don't have an accurate enough description of, the Docker file in some sense is, but in some sense you can rebuild a Docker file and you'll get a different image every time, right? Because there are always things that change. So it's at some point that becomes your atom. Like you can't actually describe in any reasonably detailed way how to reconstruct exactly that thing other than just with exactly that thing.
I got sort of a direct answer for that. It gives you invariance. So if you have some invariance, you can reason about things that you say, this is invariant across this space. That gives you a way to manage distributed systems. And like if you've got 500 machines and they should all be the same, and each of them should have one request coming in and one request going out, you've got throughput invariant. You don't have to care how many things go, how many requests it's doing, the number of input and outputs. And if one of them is doing 50% more in than out, then it's losing something or whatever. So you can find things which don't match that invariant pattern and know that they're misbehaving in some way. So I think having invariance across a large scale distributed system is one of the ways that you're able to build the ability to see what's working and what isn't working without having to kind of look at everything one at a time.
So we got about 5 minutes. Gene Kim always does this kind of give a takeaway, so what would you guys kind of want to, each one of you give a takeaway to the audience, some keen insight to something?
I guess orchestras. Let's talk about orchestras. So, an orchestra that plays Mozart every day can't play Stravinsky because they don't have any trumpets or drums. So you have to have, if you're orchestrating, you've got to have all the right things. You've got to have a conductor. You've got to get everything assembled, and then you've got to sort of get it all running, synchronize it somehow, and make sure it all finishes together, or is all working together. So that I think the analogy of an orchestra and a conductor, works at a few different levels.
Yeah, what's interesting about that, I think, is that if music is the language, then regardless of the kind of music you're playing, the people doing that work have a way to exchange their experiences, to reproduce those experiences in different ways. And that's really what you're after in this field. From my perspective, that's what I try to do, is to articulate that common language so that regardless of the piece that you want to play, you have a way to describe it to other people and share the knowledge.
So,
You always have to look when you get the mic.
the reason orchestration is kind of hard to describe, there's so many things, is because it touches on so many things. It's like automating your system. Your system is so many things. I think having a language to talk about it is really important. And I think what Docker kind of does is it kind of lifts us up. Like it got people talking more about microservices and some of the problems there. So it's at least getting us to talk about the problems, identifying the problems. And certainly Docker itself doesn't directly really solve any orchestration issues. It really kind of lays the foundation for a lot of orchestrational stuff. But I think, going forward, at once people kind of, whatever that primitive is, Docker or whatever, but some kind of Docker-like thing, we can start talking about a new common language. And I think there's some kind of competing and overlapping languages in the kind of orchestration stuff going on. And so I think, as more tools come out that gain traction, we'll kind of have more of a language and raise. And I think our ultimate goal with this is to get to that point of the cluster manager where you don't really have to, you can kind of not worry about where things are running because it sort of takes care of it for you. But that's a really hard problem. But at least people are working on it.
So I'm going to steal from a talk that was given at an Aurora meetup a month or two ago, which the thesis was that the whole goal of all of this is to reduce the marginal overhead of things. If it takes you an hour every time you have to build, an hour every time you have to deploy, you're going to get things done very, very slowly, and you're also going to want to do those things less frequently. So ultimately, deploying is still really, really hard, and we're trying to make it easier, and we're trying to reduce that marginal overhead so that you can get things done really quickly and move on and do the things you're really trying to do and solve business needs.
So I think going back to points earlier in the talk, think about, rather than thinking about this in terms of orchestration, which I view as a fairly narrow term, think about it in terms of automating your operations and everything that entails from deployment throughout the entire life cycle. And I was asked to think about what's coming in the future. So just to say a few words about that. Composable workflows, more and more self-healing systems, things that do things that are more intelligent, like scheduling, planning, prediction, and machine learning. These things are all coming, and they will make your operations easier and make it enable you to do your work even faster.